Hello. So in this video, we're going to look at the query feature that's part of the Zeno type system. So let's go ahead and enter our shell. And as you know, one of the things that we load in here is the PH library and the sys library by default. And let's take a look at the query type. So sys.Query is basically a special type that we can annotate, which basically registers a named query into the type system. Okay, and we're going to use that as part of our linting framework using this technique we call constrained queries. Okay, and this is how we're going to actually say that a particular equipment template contains an explicit list of required points. So to look at how that works, in this video we're going to look at just how queries work from a mechanism, and they're implemented with a function called query. Okay, and you can see query takes a dictionary and a slot name, and it runs that query against the database. So once again, in the previous video we talked about how the shell has a virtual database that you load. I actually have a data file here called AHU. It's just a trio file. And this is a very simple equipment model of an air handler. And I'm going to take a look at it. So we've got three pieces of equipment, nested equipment. So the air handler contains a discharge duct. And we can see he's a child of that air handler through the Equip.ref tag. And then the discharge duct itself contains a fan. Okay, so this is a nested piece of equipment in our model. Okay, of course, Haystack lets you build flat models or nested models depending on what fits your use case. But we want the validation framework to work against either case. If you want to build flat models, then your template should match. If you want to build nested models, likewise, those same templates should match. And that's what this query mechanism is going to do for us. So here's our equipment. Let's take a look at our points. And you can see that as a direct child of the air handler, we have this mode set point. As a child of the duct, we have the discharge temperature. And then as a child of the fan, we have the fan run command. Okay, so we have those three nested levels of equipment. Likewise, we have 1 point attached to each level of the equipment. Okay, so we're going to look at how the query works with that nested model. So to look at how the query works, let's take a look at these slots we've defined, which is the point and the equip. Okay, so these are predefined as in the PH library. So a query here, so point has the slot called equips. Okay, and you can see it's typed of query, and it's got this little bit of metadata here, which is it says query via, and that is a tag that's going to determine how we traverse relationships. Okay, and basically it's got this little plus sign that says we're going to traverse one or more Equip.ref relationships. Okay, so essentially this is this sort of a named query that will return all of my parent and ancestor equipments that I am contained within. Okay, so that's what this sort of point equip slot is doing for me. It's a named query. Likewise, equip has a points query. It is actually defined as the inverse of this one. Okay, so in Haystack, we typically use uprefs, so our points have a reference to their parent equipment through the Equip.ref. But if I want to do a down traversal, okay, then my query is going to be structured just as an inverse of that other query. Okay, so this is an inverse of the equips. Okay, so basically it says, okay, if you want to find all the points that contain me, run this query and find everything that matches me. Okay, so that's done with the query function, which I showed you. So let's take a look at it. So let's start off with the up pointer. So if I read a point, let's read my mode point. Oh, this is called HVAC mode. There we go. Sorry about that. So this was my mode point, and he is a direct child of that air handler. So if I pipe him to the query, and I'm going to say, show me my parent equips, okay, he's going to match that air handler. Now this little syntax may change here. What I'm doing is I'm getting the type that represents point, and in Axon, this is basically just a get of a particular slot. So this is a type that contains the slots. So this is just the syntax we're using there. That could change in the future, but that's what we're going to use for now. So I basically got that record. I evaluated that equips query, and he has one parent equip through that relationship by traversing one or more equip refs. Likewise, let's take a look at that duct temperature, right? So he was in the duct, okay, so we're going to match him. But then the duct itself was in the air handler, so we're going to match him. Okay, so he's actually got two parent equips, the discharge duct and the overall containing air handler. And then likewise, we can dive all the way down to that fan sensor or that fan run command. So let's get the run command. And you can see he's actually a parent of all three of those pieces of equipment. Okay, so once again, we're running this query here by name. So this point equips is going to run this query in our type system, and it's basically going to traverse one or more equip refs and build that resulting grid. Now let's look the other way. Okay, we're going to go to the points. So let's start off at the top level. Let's read our air handler, and let's query his equip points. Okay, and you can see he contains all three of those points that are nested within him, because he's going to perform the inverse, and then he's going to figure out everything that he is a parent of. Okay, so he is a parent of all of these points. Likewise, I can sort of walk my way down. Let's look at the duct. The duct contains the discharge temper directly, and through indirection, he contains the fan run command. And then likewise, if I actually do just the fan equipment, you can see he contains just that one point. Okay, so the query model is just a way to sort of have these named anchors to create these sort of relationship traversals. Now, what's cool about this is you can create your own named queries for whatever you want, using whatever references you have in your data model for traversing relationships. We're going to look at how this is used in the equipment templates in another video. But for now, this is just a way to sort of play around with the query functionality, once again using the query function, if I can type it, which looks like this. Okay, thanks.